I want to make a couple notes about the 2's complement of an 8-bit signed integer. So remember, when we find the 2's complement, I said that that was finding the opposite of that signed integer. It was finding the way to represent the opposite of it. So if I take the 2's complement of an 8-bit signed integer, it gives me the negative or opposite version. If I were to do that twice, then I should get back where I started. For example, if I'm looking at the 8-bit signed integer 0, 1, 1, 0, 1, 0, 1, 0, let's take the 2's complement of that, and then let's take the 2's complement of what we get, and we should end up back where we started. So remember, to take the 2's complement, first we'll take the 1's complement, change this 0 to a 1, 1 to a 0, 1 to a 0, 0 to a 1, and then 1 to a 0, 0 to a 1, 1 to a 0, and this last 0 to a 1. So there's my 1's complement. Now to make that the 2's complement, we add 1. Remembering again binary, 1 plus 1 is 0, carry the 1. 1 plus 0 is 1, and then 1, 0, 1, 0, 0, 1. Okay, there's the 2's complement. And just a quick reminder, this original number, let's see, that's 2, 8, 32, 64. If I add those guys together, this is the number 106. So this number we just found represents negative 106. Great. Now, like I said, let's find the 2's complement of this guy. So again, 1's complement first. 1 to a 0, 0 to a 1, 0 to a 1, 1 to a 0. Same thing over here, 0 to a 1, 1 to a 0, 1 to a 0, 0 to a 1. Now add 1 to the 1's complement, gives you the 2's complement. In binary, 1 plus 1 is 0, carry a 1, 1, 0, 1, 0, 1, 1, 0. Okay? Hey, look, that's 2 plus 8 plus 32 plus 64, which is 106, which is, of course, exactly what we had right here, right? So taking the opposite, just like in our system, gives you back to where you started. So the opposite of 106, which is 0, 1, 1, 0, 1, 0, 1, 0, is negative 106, 1, 0, 0, 1, 0, 1, 1, 0. And the opposite of negative 106 gets me back where I started, 0, 1, 1, 0, 1, 0, 1, 0. Okay, just one more odd note about this 2's complement thing. So it might seem totally arbitrary how we're representing these. And like I said, if you want to find out what value this is, you could just take its 2's complement. But there's another way to think about this. So if we ignore this 1, okay, so this is our negative, right? What I'm doing with the rest of this is I'm counting up from negative 128. Okay, every number over here is how much more this is than negative 128. So if I look at this number, I've got a 2, a 4, right, a 1 in the 2's, a 1 in the 4's, and a 1 in the 16's place. So this number is 22 more than negative 128. So negative 128 plus 22 gets me to that negative 106, which is what numeral that is. Okay, so you can either think about a negative 8-bit signed integer as the number that much greater in just the last 7 bits, the negative 128, or you can use the 2's complement to find out the positive version and then note that that's the negative of it. A couple of easy numbers to remember. So this 1, 0, 0, 0, 0, 0, 0 is the smallest or most negative 8-bit signed integer. It represents negative 128. Again, if you do the 2's complement there, you'll see that really quickly. And then 1, 1, 1, 1, 1, 1, 1, 1 is the largest negative 8-bit signed integer, which means it represents negative 1. Again, that's an easy 2's complement to do if you want to verify that fact.